I'm Chase from Team 974, and today we're going to discuss the topic of PID. So the first question you may have is, what is PID? Well, PID stands for Proportional Integral Derivative. Helpful? Didn't think so. Basically what it is it's called a control loop because it controls a value, maybe an arm value or a light sensor reading or something like that. So for the sake of argument, let's say we had an arm that we wanted to control. And so we've got our expected value up here, and our arm is all the way down here. Now, if it's too low, we obviously want to raise it up, and if it's too high, we want to lower it down. So that works, right? Well... So that didn't really turn out as expected. The reason was it kept overshooting on both sides, so it would go up too far, then come back down too far. So what we want is a system that can go to a specified value without overshooting. PID to the rescue! So, with a conventional control, you've got something that looks like this. So let's pretend that you've got a set of axes like this. This axis is your current value, and this axis is time. And this line right here represents also where you want your value to be at. So let's say you started up here at this point. Now you're too high, so what you're going to do is you're going to go down. But you've overshot a bit, you're now down here, so you're going to go back up. And it keeps doing this, just like this, out to infinity, which is not what we want. With PID, you've still got your same two axes, current value and time. But the difference here is, let's say you start up here, so you're taking into account three variables now instead of one, P, I, and D. So proportional, P, is the first one, and that just has to do with how far away you are. You're way up here, and so you're really far away from your wanted value, so what you're going to do is go down pretty sharply. So now you're a bit closer, so you're going to kind of, go down a little less steeply, and then now you're pretty close, so you're going to go a little bit less steep until it tapers off at the correct value. So you can almost say that the rate you're going down is proportional to how far away you are, which is kind of nice. What I does is it totals up all of this area under here, up to a certain point. So what this does is it's pretty much keeping track of how far you've been off in the past. So if you've been way off this way in the past, we'll kind of adjust it and make it go down a bit steeper so that you reach your wanted value sooner. And this is what's called an integral, the area underneath this curve. So that's your I term right there. And then your D term is, let's say we're in this position, and we're saying, alright, well, we've been going this steep in the past, so let's just say we continue it on a bit further. Well, in the future down the line, I think we're going to overshoot, so what we're going to do is we're kind of going to bring this up a little bit, make it go down a little less steep, so it doesn't overshoot. So right there's your three PID values, and what these do is they create a nice little taper off to your expected value. So in conclusion, PID is a great way to control any sort of value. We used arm control as an example, but you can do it for anything, be it line following or really whatever. So we didn't really get into the implementation in this video, so I've included a sample implementation in the description. Check that out. It's for arm control, but you can modify it for pretty much anything. But anyway, thanks for watching.